Good afternoon.
Good afternoon, sir.
Okay.
Good afternoon, sir.
Good afternoon. Okay, sorry. Sorry for being late. I was stuck with some other emergency. Okay. So we can directly start. So first of all, let me share the screen. Okay. Okay. Dynamics. Yes, today. Are you able to see the screen?
Yes, sir.
Yes,
Okay,
sir.
okay, okay. So for dynamics, don't worry that for dynamics also we are using same same writer, engineering mechanics dynamics volume 2, but will not, and that book is also around 700 pages, but we will cover only few portions. So what I thought, say to start with, say dynamics, kinematics of particle, rectilinear motion, lecture 1. And we are covering only chapter 2. Let me show you 2.1. You have to read only this one. 2.1, then 2.2. You note down this point, okay? 2.2. That will be that first one, rectilinear motion. Then we will move to one problem sheet. Then next will be curvilinear motion. Plane curvilinear motion, that means 2D case, like x, y, z. We are here only for 2D problems. I will explain everything, don't worry. So there we have 2.3, note down 2.3, then 2.4, 2.4. That's all. Then problem sheet. So 2.3, 2.4, problem sheet 2. This I will cover. Okay. Problem sheet I will provide you now itself. Okay. So 2.34 I told for curvilinear motion. For rectilinear motion, it is 2.2, 2.1. That means 2.1, 2.2, 2 by 2, say 2 by 3, 2 by 4. Basically, from this concept, problem sheet 1, from this concept, problem sheet 2. This is a rectilinear motion. This is curvilinear. I think this concept has started from rectilinear motion, curvilinear motion. I can recall NCRT class 6 also. You first got this idea, motion for curvilinear and rectilinear motions. Okay. So, and I think other state board also, they are supposed to be similar sort of concept for the first time. Just I'm waiting for, just wait. Okay. That means dynamics will start from the Newton's first law, second law, third law. There, first of all, we will get two things we call kinematics and kinetics. So motion can be at rest and sorry, state of state of any body may be at rest or in motion. At rest was the static problem. We have covered that part in mechanics, and in that static problem, it was basically it has the completeness of covering the syllabus. There are many new concepts which were not available in 10 plus 2 standard. That one we have covered, but in dynamics, statics, dynamics will not go into that advanced chapters. As I told, here it is only for today, rectilinear and curvilinear motion. Article 2 by 1, 2 by 2, problem sheet 1, 2 by 3 and 2 by 4, problem sheet 4. Sorry, problem sheet 2. So this dynamics, so it will relate to Newton's law, then law of gravitations, Newton's. Then we have some idea of units. And when we are talking about kinematics, this is the branch of dynamics which describes motion of bodies without reference to the force that either cause the motions or are generated as a result of motions. Like sometimes when you have some inertia, no, due to its motion, it will have some inertia. So in kinematics, we will not involve whatever the force involved to produce the motions will not go. So the relationship will be some sort of displacement to say time, some velocity, some accelerations. Examples are like v equal to u plus at, or s equal to ut plus half at square. Somebody a acceleration, somebody write a also, correct? And also maybe like this, v square equal to u square plus 2a s. So this type of relationship, where nowhere the which is causing the force that has been involved in kinematics. Okay, but in kinetics we will be governing for that force required to produce that one, like p equal to ma. That type of relationship is kinetics. So today we are covering this kinematics portion only. Okay, so kinematics we will consider mainly for the case of the particle. Okay, particle is a body whose physical dimensions are very less compared with the radius of curvature of its path that may be or that may treat the motion of the particle as that of a point. Okay, so although reality it is 3D body, we are now covering for the particle. Okay, very small body, or maybe point also you can consider. So you have to read 2.1, 2.2, 2.3, 2.4 for kinematics, nothing more. Okay, don't be confused by seeing the volume. Kinematics. And we will solve some classic problem using the problem sheet, which I will be giving today itself. So first of all, say we have three-dimensional state like X space we called. It is space basically, three-dimensional space on which one particle is moving like this. This is the movement of the particle in 3D, maybe like this. So this is the movement of the particle. Now say one point, say A, other point is say B. Within this point A and B, one point you consider say P. If you see P has the coordinate system. P has the coordinate system based on Cartesian coordinate system. It is having some distance x, some distance y, some distance z in Cartesian x coordinate x, y, z. Maybe for 2D, this is 3D problems. For 2D problems, it may be x and y. Z is fixed, maybe z is 0. One. Other one is we called that it is we can represent by r. This is the r. Maybe this is the theta, r theta, and maybe z, r theta z. Okay, cylindrical coordinate. Okay, Sometimes we can have r, theta, and phi. We call spherical coordinate. Different types of coordinate we can consider: Cartesian, cylindrical, and spherical coordinate. R, theta, z. Now, so we can have choice of the coordinate based on your own understanding. Sometimes I forgot. Sometimes we call that this is some path, and we may have some tangential coordinate and normal coordinate. Tangential, tangential, T, normal, N. Like when we want to calculate, say, some sort of centrifugal force, okay, some accelerations toward the center, or maybe I have, say, for example, I have one pipeline. This is the pipeline pipe with some bend, and this is the cross sections, okay, hollow pipe, and here maybe it is looking like this, 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 okay, and some fluid is passing through that. Some fluid is passing through this uh, pipe, okay, or somebody can write in continuous line like this, okay. This is the continuous line, maybe this is another line. We called this streamline. This term maybe you have heard, streamline. Okay, where at each point, if you draw the tangent, that will represent the velocity of the path, imaginary path. We call streamline. Now, for those case, when you have one fluid flow, fluid mechanics basically, fluid mechanics. So global coordinate system may not be helpful, because global coordinate system means, say, this is x, this is y, that is z. That is not be helpful for doing the analysis. You need some local coordinate. Local coordinate. Okay. This is the global coordinate. Okay. Maybe this local coordinate is a function of global coordinate, but local coordinate concept is required to solve those type of problems. And maybe in that case, many times we need normal and tangential coordinate. This is a normal, and this is a tangential coordinates. Okay. So this is the choice of the coordinate systems. Okay. Choice of the coordinate system. We can simplify the problems in a plane motions, 2D. Everything we are considering in 2D. In books, you can read 2.1, you will get more information. Now, as I told, in 3D, particle can move any arbitrary path. Then we can have XYZ coordinate, or maybe R theta Z coordinate, or maybe R theta phi spherical coordinate in any arbitrary case. But when one particle is moving along a straight line, along a straight line, so we called that type of motion as the rectilinear motions. That means this is 1D problem. In rectilinear motion can be considered as the 1D problem. Say this is x, and this is y, and this is z. Okay, so only x is enough to represent that type of movement, and maybe this is some plus s. S stands for displacement traveled by one particle within some time. So this is the s, and this is plus s, this is minus s along the x-axis, and this is some distance s, and this is delta s. This is delta s. So you know that from the concept of velocity, average velocity was v average velocity was delta s by delta t, and instantaneous velocity was ds by dt or s dot. Somebody write x dot also. Some books can write x dot dx dt. Okay, dx dt is the velocity, but you also know that this instantaneous velocity is a vector quantity, and this is the relationship. I am just recovering 10 plus 2 standard things, don't worry. So in similar way, average accelerations will be delta v by delta t. Okay, and acceleration will be instantaneous. Acceleration will be dv dt or v dot, okay, or maybe s double dot. Any way you can replace. You know, dv dt d squared s dt squared s double dot. Now this relationship, from this relationship, that a equal to dv ds, somebody can write that this way, that a sorry dv dt, okay,
DT.
dv dt, yes. So dv dt a equal to dv dt, that relationship we can write here. From this, let's write dv equal to, this is dv equal to a dt, okay, dv equal to a dt. Then if I use this dv, just a minute, a equal to dv dt, a equal to dv dt, correct? Then we want to write what is the value, say v dv, maybe if we write this way also, v dv, or maybe I want to write this in different way, I can prove this. I'm trying in a simple way such that maybe a ds, if I write this way, a ds equal to dv dt ds, or dv ds dt, then we can get this as a v dv. That way we got this relationship, that v dv equal to a ds. And you know, from this relationship you can get that v square, v square by 2 minus v2 square by 2 minus v1 square by 2 equal to a s2 minus s1. That type of relationship you can write. Or maybe in terms of derivative form, s dot dv, this is v dv equal to s dot, then s double dot ds. That relationship also you can get. Why I am writing this in numerical problems? Some classic problem will you solve where this type of relationship will be used, which you might be knowing from 10 plus 2 standard also. Now, what is the graphical representations of that? Okay, what is the graphical representation of this graph? Okay, or as I told, that dv ds, that type of relationship. Now, first of all, to start with, you know that this say a equal to dv dt means this is the slope of the curve. A will be the slope of the curve, okay, or maybe b equal to ds dt, slope of this st curve. So this is the s, so this is the t. So at this particular point, if you draw one tangent, then this slope will be it will give instantaneous slope, will be giving the value of v. So slope of the curve, we will be using the concept slope of the curve, that is nothing but derivative, curve. So now if I have s versus t one graph, so here this slope will be the value of v. That's why here it is been shown, let it be 1, and this is v, that is ds dt or s dot. Okay, so that is ds dt or s dot. Now our first target is, if I draw this slope, first of all I have s versus t, that graph we have s versus t, s versus t, that is the particle moving with time, that representations. It may be function of t, s equal to function of t. Now, if somebody want to draw the slope at different places, you draw one slope here, different places, you draw the slope. Then the slope, whatever you will get, you take the slope and plot it again. and plot it again. The slope will be velocity and this will be time. So the v versus t you can get from this instantaneous slope at different places. At different places. So dv dt, once again the slope of the dv dt will be value of a. Acceleration will be, a deceleration will be dv dt or v dot. dv dt or v dot. Now, if you look carefully, say I have v versus t graph, and this is the representation of v versus t graph. Now, if I consider similar way we did many times, one element, this is the one small element, very thin, thickness is delta dt, thickness is dt, and if this v versus t, then this value will be v. So this is the v, this is the t. Then what is this? Area, elemental area, dA, this elemental area. What is this elemental area? This elemental area is nothing but v multiplied by dt. This area is v, this area is elemental area is v multiplied by dt. Okay, this elemental area dA, this area I am talking about. On the other hand, what is this area? From the relationship we got, v equal to ds dt. So this is v dt, this is the v dt. So this dA is nothing but ds. ds equal to v dt. That you v dt. And if you do the integrations, from t1 to t2, from t1 to t2, then you will get s2 minus s1, that is nothing but area, total area under vt graph, vt curve. Let me curve. That means that the distance traveled between two times t1 and t2, distance traveled by the body, it is rectilinear motion. Be careful. We are discussing rectilinear motions. In rectilinear motions, the distance traveled by the particle between two instant, two time, t1 and t2. So S2 and minus S1, that is nothing but area under V versus VT curve. That is nothing but area under the VT curve that we got. Now, if I concentrate this accelerations versus S, acceleration versus S, this is one relationship. Say acceleration is a function of s, distance, function of distance traveled. Then, and this is the graph. How I am getting this relationship? One particle is moving in reality, say in rectilinear motions. Somebody has observed and find out and formulated in the form of a equal to function of s. Somebody did this job for us. And this is that function, see, arbitrary functions. Now for this arbitrary function also, if somebody want to take one small elements like this, so here say here dA1, so here this elemental area dA, this is a 2, what is dA2? A multiplied by ds, a multiplied by ds. But ADS we have seen before. Yes, ADS is nothing but VDV. That is nothing but VDV. So we'll write here VDV equal to ADS. If you do the integrations both side, so integrations from 2 points, maybe velocity. So v1 to v2, velocity is v1 to v2, and here it is t1 to t2. Sorry, S1 to S2. Here it is S1, the S2, S1 into S2. Then we can write that half V2 square minus V1 square equal to area under AS curve. And what is this? This is the change is kinetic energy per unit mass. Half V2 square minus V1 square is change in kinetic energy per unit mass. That is nothing but the area under the AS curve. That is nothing but the area of the AS curve. Okay. So similar way, if I have accelerations versus time, and this small elements is this dA3 equal to A dt. What is A dt? We have shown here before. A dt is dV, is not it? A dt is dV. So this dA3 is nothing but dV. So integration over V1 to V2, this is integration over T1 to T2 A dt. That means V2 minus V1 equal to area under A T curve. So what we have learned from this exercise, initially we have S versus T. One graph we are having from within T1 and T2. If we can take instantaneous slope for different places, we will get the velocity ds dt s dot. Different places, if I take that instantaneous velocity like here, whatever velocity I will be getting, if I put here as the velocity at the time, then I will get from S T curve, S versus T curve, I can get VT curve by doing the derivative, and this is the VT curve. And this VT curve shows that instantaneous slope is nothing but accelerations dV dt, and this velocity acceleration A dV dt, I can show that that S2 minus S1 here, this is distance S, that S2 minus S1 is nothing but area under VT curve, area under this VT curve. Now we got here acceleration A. If somebody want to do the another derivative like dA dt, okay, or maybe do this way. This is the acceleration, put here this acceleration, and this is the time. So if somebody want to draw the slope here, that is dV dA dt. But dA dt is not that much of significant. We are not showing that. But what we can show, taking this elemental area, that V2 minus V1, change in velocity in rectilinear motion is nothing but area under the AT curve. You have to be careful here. This here A is inside the integration. I have not keep it here. Why I have not keep it here? Because this acceleration may be function of time. This is not constant. This velocity is not constant here. Acceleration is not constant. S naught is not constant. A is also not constant. It is arbitrary. But when we know some of the values are constant, we can keep it prior to the integration point as the constant value. It will come out from the constant terms. Okay, so as this is the constant. Now if the given problem, if any problem given to you, function given to you, you can solve this type of problem and you can get the solutions. Nothing more. Just I am highlighting this representation, physical signification or graphical interpolations of the different curve. Okay. So we got VT curve, ST. From at the beginning we got ST curve, then we got VT curve. From V we got AT curve, and finally another one we have shown A2S curve. And what we have learned that change in distance traveled by a particle with a particular time is nothing but area under VT curve. Okay. Then we got change in velocity for a certain time interval is nothing but area under the AT curve. Here we got that change in kinetic energy per unit mass will be area under the AS curve. Those are the physical representation of different way you can analyze rectilinear motions. Okay, so it has been shown here. So, and this is 2.2. You can 2 by 2 article you can read from the books. Now, when we have constant accelerations, yes, as I told, this acceleration can be come out from here to here. And this relationship, you know, in 10 plus 2 standards, this is the standard relationship. Now, as I told, this acceleration may be function of time. If acceleration is a function of time, then the dv equal to a dt. So, this is a function of time. Okay, so it is this dv will be current is V from the V0. So V minus V0 or V equal to V0 plus this expression. Now I can give in exam or in assignments A equal to ft. That function I can provide you. You have to just do the integration. Sometimes you have to do the derivative. Sometimes from the graph you will get some constants and find exact value of the displacement, velocity, or maybe distance traveled you can calculate in rectilinear motion. Okay, say like here ds equal to v dt. Okay, and this relationship is s2 minus s1 or maybe s2 s0 initial, this relationship. Acceleration is a function of fv, function of v. Then t equal to integration of 0 to t. Okay, and dv equal to a dt. That relationship will be dt will be dv by a. A is, so this is dt will be dv by a. dv by a equal to function of v. Okay, somebody can do integration t equal to 0 to t dt equal to say v0 initial to v dv by function of v. We don't know this value. Okay, if dv equal to only v, then dv by v, ln v, or whatever value you will get from the given problems. Sometimes it may be a is a function of fb, and somebody can use this relationship b dv equal to a ds. You replace a by fb and put this and get this relationship. Don't worry. Given a problem, you can easily express this type of terms. Acceleration is a function of distance. Okay, so this one you have replaced with function of distance. You can get this relationship. Simple one is, say this acceleration is constant, then it will come out from the integration point. That's all. So this is the different from. Don't worry. Given a problem, you can easily set this. Say one example is given. I will write this v equal to 6t square minus 24 meter per second. It is given. Sorry. It is given here. S equal to. Sorry. 1 minute. So it is given that S equal to 2t cube minus 24t plus 6. Somebody can get v dv dt. Oh, and from this you can put t equal to 0. When t equal to 0, s equal to 6. So this is say t equal to 0. So s equal to 6. This will be s in meter. T will be in second. So s in meter. This is the graph. T in second. So when t equal to 0, s equal to 0. Okay. Or maybe when s equal to 0, somebody can calculate what is the t value. This parabolic expression you can draw using Excel, using MATLAB, different software you can use to draw this. Okay, graph paper you can draw this. This is the S variations. So somebody can get v equal to dv dt. Okay, and you can see it is meter. So S will be in meter. This will be in meter. So v will be meter per second. Acceleration will be meter per second square. That you know first. You do the derivative of this, you will be getting v. You do the derivative once again, you will get the acceleration. Say 12t is the acceleration. When t equal to 0, Okay, this is the acceleration. Okay, and now interesting thing is, say v equal to 6t square minus 24 meter per second, meter per second square. So somebody can draw this, no? This parabola expression also. T equal to 0, v equal to minus 24. So somebody can draw this. Somebody can get this idea of this graph. Then a equal to 20 t, y equal to mx, c equal to 0. So slope will be 20, sorry 12, sorry, a equal to 12 t. So this is the slope will be 12. Yeah, this is the slope. This is 12. Somebody can write this is 1 meter per second square. Now, based on this, if somebody asks that calculate, determine the time required of the particle to reach the velocity 72 meter per second, initially t equal to 0. 72 meter per second you have to reach. B equal to 72 meter per second, at what time you will get? You can have v equal to 60 t square minus 24 t. You put that value of v equal to 72 meter per second. You will get the time required. When the particle will get velocity is 30 meter per second. Okay, what will be the accelerations? So what time is required to reach that velocity? You get the time, then you calculate time is here time is 3 seconds. So acceleration will be 12 t. T is 36 meter per second square. Net displacement of the particle during the interval t equal to 1 to 4. T equal to 1 to t equal to 4. What is the distance traveled? What is the distance traveled? Many ways people can do. So distance traveled is s4 minus s1. This is the s expression given. So t equal to 4 is the s4, t equal to 1 is the s1. You will get the value of the s2 minus s4 delta s value. Or somebody can use that area under which curve distance traveled. You go back. Here we have done distance traveled. S2 minus S1 is the area under the VT curve. Area under the VT curve. Now come back. Area under the VT curve. So yes, this is ST. Somebody can VT. Now this is the area under VT curve. This is time T1, T equal to, this is 4. Now somebody can do the integrations and calculate. Somebody can do the integration from T1 to T2, okay, with the proper form, and can get the distance traveled between the time T4 and T1. That also you can do doing the integration, or simply S4 value, S1 value, subtract S4 minus S1, you will be getting the value of distance traveled. Just a minute. Let's show the one assignment. Problem sheet 1 basically. Problem sheet 1. Problem sheet dynamics. Yeah. Just wait. Dynamics. Open with. Yeah. I will give you the problem sheet. Don't worry. So now it is told that some velocity of the particle is given this expression. V is meter, t is second. Meter per second v, t is second. Plot the velocity v accelerations versus time for first 6 seconds of motions and calculate the velocity when a is 0. So you know the v, what is the acceleration, dv dt, whatever time given, you put this and you will get the answer correctly. I am not going that. Okay, you solve this. If you are facing some issue, I will solve you. I will help you to solve. Maybe we will solve these problems. That one particle is moving along the positive x-axis with an acceleration ax, that is in meter. X is represent in millimeter. So accelerations here equal to that, it is related to ax. This is the okay, as shown in the graph, x is millimeter. Okay, for the velocity of the particle at t equal to 40 mm, t equal to this is x equal to millimeter, 40 millimeter. The acceleration is ax, meter per second square. When it is 40 millimeter distance, velocity is 2 meter per second square. But when when uh,
Sir, acceleration is 2, right?
this is the accelerations. Just a minute. 0.4, correct? No. Okay. This is, it is told when at if the velocity of the particle at x equal to 40 is this. At the this figure is telling x equal to 40 mm, velocity is 0.4 meter per second, not sorry, meter per second, not available in graph. Here acceleration is 2 meter per second square. Okay. When this figure says when x equal to 120, here your acceleration is 4 meter per second square. But we have to calculate the velocity. X equal to 120 mm, acceleration from the graph, it is 4 meter per second square. You have to calculate the velocity. Okay, now tell me what to do to solve this. What approach you want to adopt?
Acceleration is equal to V dv by ds.
Acceleration equal to dv dt.
V dv by ds. V dv by ds.
Oh, v dv by dx.
ds.
Okay. Then,
By integrating, sir, and putting the limit, we can find.
okay, but acceleration is not constant. It is varying. Velocity is varying. Acceleration is also varying. Acceleration is varying linearly with x. Acceleration is varying linearly with x.
We can relate the A and X.
Hmm. A and x. Okay. Yes, you can do. Okay, fine. There could be many ways to solve this. Say, for example, I can utilize this expression v dv equal to a dx, is not it?
Yes, sir.
A dx and do the integration. 0 point velocity 0.4, sorry, 0.4, yes, 0.4 to, we don't know value this, and this area is nothing but area under ax curve. We told that one, correct?
Yes, sir.
And then this area you can calculate easily, and this will be half b square minus half 0.4 whole square. You can get that one. So what we can utilize, simplify that. That area under this graph is a dx, is not it? A is varying a dx and area under the graph. How you can calculate any area under the graph? You can divide this way. Okay. This way, one is this area, other is this area. You can do no easily using that concept.
Yes, sir.
Yes, sir.
Yeah. You that way you utilize. You have. I'll be putting you the assignments. Due date also will fixed. Don't worry. Okay. So there are 8 problems we can do. Next chapter I can start. Hardly it will take 10-15 minutes. Now we are here with the curvilinear motions. Motion is not straight line, it is plane 2D. That means it is XY plane. XY plane. So, say for example that there are 2 instants. One is A, after some time, little bit small interval, it is A prime. This is the particle positions, and this is the path of the particle. This is the path of the particle. Now, this actually is actually for these 2 points A and A prime, maybe say from reference 0 Position vector is r. Position vector. Position vector is r. R is the position vector at A. For at A prime, it is r plus delta r. So r plus delta r. Vector in vector position vector. And this, if you form this triangle, okay, closed loop, closed triangle, then delta r is the change in position vector. Delta r is the change in position vector. Okay. So delta r is the vector. Okay. This is the straight line vector. This is the straight line delta r from the triangle you have formed. But you can see what is the distance traveled, little bit higher, no? This one due to curvature. The distance traveled is delta x. In this problem, delta is greater than delta r. This example basically. Distance traveled is higher than the delta r should be, I am writing here, okay, to avoid confusions. This distance traveled is little higher than the delta r because this is a straight line triangle. Now along this delta r, if somebody want to divide by delta t, okay, so then you can get average velocity. This delta s by delta t, okay, average speed, you can get average speed. Okay. Now somebody want to do the calculate the instantaneous velocity, so definitely you will get, you'll do dr, sorry, okay, dr by dt, yes, dr by dt, here you will get velocity. Here you take at that conditions instantaneous velocity v prime. Let me tell you this way, time r delta t, this. Okay. No problem, I'll come here. So this is the v average, velocity average. Okay. Now instantaneous velocity will be getting this. Or we simply write drtt. And as I told, this delta s is a scalar scalar quotient, and that is that will be very close to the delta r when these two intervals a and a prime, they are very close to each other. And also we can get this velocity like r dot. Now you come here. This is the position vector r plus delta r. This is the delta r. This is dr dt at A, dr dt at B, and we are representing this by slope, okay, tangent V and V prime. Now if it is V and this is the V prime, if it is V and is a V prime, from the triangular law, this is the delta V. If it is V and this is V prime, and we are drawing, and V, this A and A prime are very close, we want to draw this V and V prime, then delta V will get. Along the delta V, along this delta V, see, acceleration will act, because that is dV delta t or dV dt, is not it? That slope will be along this, and it will be along this accelerations. Now this acceleration may be two things. This acceleration, any acceleration can be like this way. A, it will be ax, ay. We can have x and y directions decomposed, or maybe if this is the A, somebody can have this is an normal and at. Okay, that way in curvilinear motions, many times we got this accelerations, centrifugal accelerations in normal directions along with the tangential directions. But sorry, vectorically this will be total acceleration part. This is the total acceleration part. What is the total acceleration? That is acting along delta V. Should I repeat this once again?
Yes, sir. Last part.
Yes. So it was easy. R plus delta R. Delta to delta t or dr dt, instantaneous velocity v prime. at A and A prime. A and A prime, they are very close. This portion is fine. Now, if I want to draw, this is the V, this is the V, this is the V prime. So then this will be delta V. Along this delta V, your acceleration will act. This is the A. Along the delta V, okay, because this is the from the triangle equilibrium, we can get this delta V concept. Okay, along this delta V by delta T is the average accelerations. This dV dt is the accelerations here along this line. Now this acceleration can have two parts. I can decompose into two parts like ax or ay in x and y coordinate. Sometimes what we used to do, say this is the accelerations, we can decompose into just a minute. So okay. So this is the accelerations. We can decompose into two parts. One is tangential acceleration and another is normal acceleration. An, this is n normal direction. This is t direction and this is at and this is the an normal accelerations and this is the tangential accelerations and this is ax and ay. It is basically decomposition of a accelerations in xy coordinate or maybe in normal and tangential coordinate. Okay, and that acceleration is nothing but that is acting along delta V. Delta V is nothing but we are getting 2 points V and V prime, A and A prime velocity. The difference between V and V prime magnitude and direction wise delta V. Along delta V acceleration is acting. And velocity we are getting from velocity for this point and this point we are getting by dr dt, instantaneous slope. If we can have position vector function, we have r equal to some expression dr dt at t1 and t2. T1, T2 are very close. Those are A and A, B. Okay. So you can get V prime, delta V along that directions. Acceleration can be decomposed as per your own understanding in rectangular coordinate x and ay or maybe normal tangent coordinate nt. We call nt coordinate. Okay, acceleration an and at. Is it okay now?
Yes, sir.
Okay. So, and this is the speed. This is the magnitude. Nothing is required. Acceleration already explained. Okay. Now, here maybe somebody is interested to consider that R1, R2, R3. This is the three position vector. So you take the slope of the curve to position vector, you will get V1, R1 dot. At this point, to get the slope, R2 dot. At 3 to get the slope, R3 dot. So this is the basically path of the particle. This is the path of the particle. And position based on the position vector to take the slope to get the derivative of this position vector, we can get V1, V2, V3. Now, if somebody want to consider one fixed point, any point, any arbitrary point, C, through which you want to draw V1, V2, V3, both magnitude and direction wise. You take one reference point on any arbitrary reference point, and from that point you draw V1, V2, and V3. So what will get magnitude and direction wise? 1 point, this is 3 points. Now you draw these 3 points and extend. You will get one graph that is known as hodograph, HODO, GRAPH. This is the one imaginary graph. And you can assume that if this is the v, then v dot will be acceleration at here, v2 dot will be acceleration here a2, v3 dot will be acceleration here a3. That means similar way, here it was position vector r, here it is velocity. Here doing the derivative, your position vector, you are getting velocity. Velocity, doing the derivative, you are getting the accelerations. That's all. Now, you consider, as I told, some rectangular coordinate. So, in rectangular coordinate 2D case, 2D case if you have, then position vector, sometimes we can write r equal to xi plus ij, or v equal to r dot this, acceleration v dot this. So this is the component wise. R has two component x and y, velocity has two component x dot and y dot, acceleration has two component x dot y dot. Now based on this, somebody can have some scalar quantity like vx equal to x dot, vy equal to y dot. That way I am writing x, y, then x dot, y dot, 2D case. Okay, ax equal to vx dot or x double dot, ay equal to vy dot or y double dot. That way you can write. And we know velocity is this. Velocity is square root of this, and tan theta equal to this. And acceleration is this. And then maybe this tan phi equal to ay by ax. The way I told before also, correct? That's fine. Now, maybe this is the path. This is the path of the body. This is the path of the body. Okay. Now, this is the position vector v. This is the position vector v. Sorry, r. Okay. R has two component xi, yi. Yj. This is I. Position unit vector j. This is x and this is the y. So, from the r, you can get velocity say v. V can has two component vx, vy. This is the scalar quantity. This ax and y scalar, vx is scalar, vy scalar quantity v. Then maybe acceleration is ax and ay. So vx, vy, ax, ay, those are the scalar quantity. Scalar quantity. So angle is associated with what? Here say it is theta. Here it is say phi. So it is scalar quantity. It is associated with some angle theta. If you know the theta and vx and vy, then easily you can get the actual vector. You can get the actual vector. Okay. And as by default, Vx and Vy are at 90 degree. Vx and Vy, X and Ay are 90 degree apart, 90 degree to each other because of rectangular coordinate. So theta and phi also known. Okay, theta and phi is also known. Now based on that concept, in 10+2 standard, you read this projectile motions. Where in projectile motions, where is projectile motions? We have some projectile like one object like this. So we have some object like this. Somebody want to throw with some velocity, say v0, and v0 supposed to have two component. Okay, so v0 supposed to have v0 supposed to initial velocity supposed to have two component here, vx0 and vy0. Okay, and here there are two things acting basically. Acceleration has two component, ax and ay. Ay is nothing but acceleration due to gravity. Ax equal to 0 provided we are not considering any disturbance due to drag force or the aerodynamics. So if it is so then Vx component Vx0 it will remain unchanged. As Ax equal to 0, Vx0 will remain unchanged. So this Vx will remain unchanged and Vy will be changing accordingly. Acceleration g, ay equal to minus g, that is constant. Okay, that is constant, is not varying. As this is constant, it will come out from the integrations, which I have shown before. There are different integration formula. Uh, but yeah, so the velocity, correct? So yes, so like a was function of second here, but here a equal to constant. If a equal to a equal to constant, acceleration equal to minus g in this problem. If it is minus g, then definitely distance traveled along x direction will be x0 plus v0 xt. Y along y distance it will be y0 plus v0 vy0 t minus gt square, or vy square equal to this relationship, you know. Now based on that, yes, that is the problem. V0 initially, this is vy0, vx0, this is constant, this is g. So v is changing like this, v is changing is like this. Vx will remain constant, vy will be 0 here. At the top, okay, vy will be 0. When vy will be 0, vx, only vx will act here. Vx will remain same. So Vy based on the value of t or other terms, it may be Vy may be positive and here it may be negative. And maybe instead of this, you have some angular or angular incline. Somebody can throw one ball like this, and you can calculate how many distance traveled and so. And you know remaining things in 10 plus 2 standard. I am not going into details for that. That's all. Then we can solve the problem sheet 2. Okay. Just give me 1 minute. I can give the assignments in your classroom. Just wait, okay? Then it will be easy for you. Just a minute. But date I am not fixing, so I am giving the assignments because it will be good for you also. Just a minute. Just hold on. Dynamics. Okay. Just hold on. Let me 1, 2, 1. Just a minute. I have to split the whole structures. 1 minute. 1, 2, 2. 3, 2, 4. 5, 2, 6. And 7. Just hold on. 1, 2, 2. 3, 2, 4. 5, 2, 6. Then 7. Then 7. Just 1 minute, okay? Problem sheet. Just hold on. Lecture. Problem sheet. Okay. Statics. Dynamics problem sheet. Okay. So just let me. This is problem sheet 1. Problem sheet 1. Dynamics. Problems, dynamics, rectilinear motions. Rectilinear motions. Rectilinear. Motion. Curvilinear motions. So coursework, create assignments. Let's check whether you have received problems sheet 1 dynamics and confirm whether you have received or not. Have you received?
Yes, sir.
Yes, sir, received.
Yes.
Yes. The second one is curvilinear motion. Curvilinear motions. Curvilinear motion. Curvilinear motion is xt. Curvilinear motion. No, it is x and t. X, y coordinate. Just hold on. Create assignment. Okay. Curvilinear motion. Problem 2. Curvilinear motion, rectangular coordinate. Normal and tangential. Okay, xy. X, yes. Okay. Now check second one.
Yes, sir, got it.
Okay, very good.
Yes, sir.
Okay. So these two assignments are related to this dynamics, rectilinear and curvilinear motions. Okay, I have to solve one problem for curvilinear motion now. Let me share the screen then. Okay. Problems are very simple. You try. So what I will do next day, after this class, I will upload another 2 assignment also. Okay, kinematics another 2 problem assignments will be as problem sheet 3 and problem sheet 5. 4 is not. We are not giving this. That was spherical coordinate. We have excluded that part. Only cylindrical coordinate and rectangular coordinate we have considered here. Okay, so 2 assignment also I will put there for your understanding for kinematics. And these assignments will be 4 assignments for kinematics only. For kinetics, there will be no assignment. We will not get much time. So your idea will be once this has been given, you try at your own. You are facing issue. Next day you will ask me. So what I have planned next day in kinematics, another 2 chapters I will finish. Then next Tuesday, next week, whatever the problems you are having for kinematics, problem sheet 1, 2, 3, and 5. Okay, around 25 problems. If you are facing any issue, I'll solve that everything. I'll give you hints. Then after that, kinetics will start. Five problem sheets more. So I have planned within 4 days. This kinetics will be that portion will be covered. Total 7 days, including apart from today, only 6 days to cover the syllabus. Such that one day will be exam, one class test, which I have planned, and one day will be revision for my entire syllabus. Okay. Now let's come back here. Yes. Yeah. Tell
Excuse
me.
me, sir.
Yeah. Tell me.
Sir, do we need to submit the assignments or we need to just practice the problems?
You have to kinematics 1, 2, 3, and 5. You have to submit.
Okay.
When I'm giving something as the assignment, you have to submit. What else I will give you as the study material or some material. The way I have given that moment of inertia 6.123, you see that was not as the assignment. Okay.
Sir, give
Sir,
that
here the
notes
due
now.
date is not showing.
No, I'm not given now. We'll decide after that. Okay.
Okay,
Okay.
sir.
Maybe now itself we can decide. Just tell me. Okay. Yes. You tell. Let me check here. So see, today is on 4th. I will give another 2 assignments. So due date maybe we can plan. Maybe 13 is okay. 13. Today I have given 2 assignments. Next Friday I will give another 10 assignments. Total 20 or 25 assignments. Due date is 13 is okay. Is it fine? 13.
Okay, sir.
Yeah. I'm giving both as a 13. Okay. If you are facing some issue, then maybe we'll think later. I can extend also. But you have to be ready with the class test on 28. We are very schedule bad timings basically now. Okay, let it be 13. Uh,
So
both.
class test will be online or offline?
Okay, good question. Uh, which one do you think better? I will give you one hint. If it is offline, preferably all problems will be problem sheet. Okay, easy problem. Without some problems will be without changing any data. That is the offline exam. If it is online, problem sheet will be new. Okay, you know the way we are giving. Which one do you prefer? I have no issue.
So I guess
Sir,
online.
online. Sir, online.
Okay,
Sir, at
Sir,
this moment,
online. Sir, online.
sir, will the college is it sure that it will reopen for us at 21?
see, I have to follow the instructions. There is no comment from my side. So what I can say, as per the notification received from the component authority, your offline class supposed to start from 21. No
Okay,
more
sir.
explanation. Understood?
Okay, sir.
That means till now college is planning like that. If there is any further notice, it may change. We don't know. Okay.
Okay, sir. Yes, sir. Actually, we also don't know properly. We have just heard that 21 college will start.
But college is trying their best to do so. Okay.
Okay, sir.
College is trying hard to reopen the students so that all students can come. I'll tell you, the fact is, say you are first year and you have only 10 days before your first semester. So question is whether 21st is okay for you to bring all the students
Yes,
from.
sir. Sir, because actually many students will come from outside
Yes,
states
yes,
and all.
that is the
They have to get
big
adjusted in hostel and all. Like in 10 days,
yes.
it will be difficult.
Yeah. So those questions, if you have that type of questions, everything, so you can. I should not tell all those things. Okay.
Okay,
I'm
sir.
just
Okay, sir.
a follower of the instructions. Understood?
Okay, sir. Thank
You
you.
are intelligent guys. What I mean to say. Okay.
Yes, sir. Yes, sir.
Don't worry. So whatever instruction I have to follow. I cannot do anything. Now what I can do, as I told, that this class test, whether online mode or that can I do class test. That is with me. As per your as you wish, we can do plan accordingly. Okay.
Okay, sir.
So I will tell you, I am giving 13th date. you try to finish this kinematics part 4 assignments by 13 itself and upload. Then your effort will be very less for the dynamics portion. I'll tell you some way. I'm telling this way. Say in final questions mechanics there will be one portion dynamic, other portion is statics. Two different portion. From the static you have to give answer for static. For dynamic you have to give answer for dynamics. This is one way one question can be, or else there is no division between static and dynamics. You have to answer any 5, provided question number 1 will be from moment of inertia compulsory. Answer question number 1, that is from moment of inertia compulsory, and answer any 4 from the remaining 6. Then there will be some static problem, there will be some dynamics problem. Got my point?
Okay. Yes, sir.
Because we have not decided yet. So what to?
Excuse me, sir.
Yeah, tell me.
Sir, in case of offline exam, then the pattern of exam will change.
Yes, 3 hours, I guess.
So then suddenly this pattern will change in.
No, my pattern will no. Our question will be same pattern. We will not doing anything change. Understood? Same thing. I'll tell you. If it is 1.5 hour exam, 50 marks, 1.5 hour exams. So you have to answer any 5 out of 7 questions. Say you have to solve the problems, numerical problems, the way you did in class test, midterm, similar. I am not changing anything. But other teacher, I cannot. I don't know. I cannot comment also. Okay, understood. But what I am giving emphasis on, if you can complete by 13th, these 4 problems sheet around 20 or 25 problems. Then remaining 25 problems will be there. Total 44 problems dynamics. This is the good thing for you. Total 44 problems from dynamics, including kinematics and kinetics. 44. So if you are very serious now, and many of the things you know in 10+2 standard, in many of the coaching standard you have learned this. Maybe you forgot now. If you work hard for the dynamics only, then definitely you will be able to answer minimum 3 questions out of 5 from the dynamics. Minimum 3 questions from out of 5. Total 5 questions you have to answer from the dynamics. This concept is enough to solve that. Out of 50, you can score 30 easily. Then remaining 20 from the statics. If it is part A, part B, one way, then if it is there is no division between statics and dynamics, then one compulsory question will be from moment of inertia. I can say this way also. So there is no partition, statics and dynamics. Then one compulsory questions from moment of inertia. And if you know only dynamics, then remaining 4 questions you can answer. At least I have to set 4 questions from the dynamics out of 7. 3 will be from statics. So 4 questions itself you can able to answer if you know only dynamics. 44 problem. That way you can score at least 60 minimum score. I am telling 60 score you can easily do. Now next question is to score more than 80 or more. Then you can be very many of you who score good in midterm, they know statics. Everything statics part is very strong for them. Then it should not be any issue. Once again, I am telling this subject is 4 credit, 100 marks. So if somebody want to change department, you need good score. Then this mechanics subject can survive you for changing the department. Have you understood? Or many times, many companies are asking your high good CGPA to appear in the interview. Then mechanics subject can help you to have good grade. At least 70, somebody can get 70. 70 means CGPA 8. Understood? This way also you can plan. Now coming back, time is, so what I told, 13, correct? This will I'll give it here, edit due date 13. This is rectilinear motion. Rectilinear motion. Then this was curvilinear motions. Marks is 10. Okay, updated. Now I'll solve only one problem before I want to leave for the day. Okay. For problem sheet 2. Okay. Just I want to tell you that you have a roofer tosses a small tool towards the co-worker on the ground. So this person is throwing this ball with some velocity v0, and this is the man. It is told that what is the minimum velocity v0 is required so that tool clears point B here, and locate the point of impact by specifying the distance s shown in the figure. This is the s. You have to calculate this. So simple. You will use your concept of the 10+2 standard projectile. Then you can get the solutions. So what you have to do? You have to be careful that if you consider, say, it will some time will be required. Say here, say one time is a TB, here one time is a TC here. Okay. Now y equal to y0 plus vy0 t minus half gt squared. That relationship you can use. So
So we
here,
can use the formula for range.
yes, you can apply formula for range also. This
Yes,
also
sir.
you can give, but
That will be simple too.
is it? No, y0 equal to 0, vy0 equal to 0. Okay, if you write -3 equal to minus half gt square, then you can get t easily. Okay, t equal to say 0.903 second. Then as you told, then you write x equal to x0 plus vx0 t. Okay, this you write x0 is 0, v0 x0, v0 x0. See, as per the problem, this x supposed to be 6. Wait,
Sir, y is 4, right?
4.
Minus
Just
4.
-4. Sorry, -4. Yeah, I missed this. Yes. So that type, don't do that type of mistake. Then you can write this distance, then t you know, v0 you don't know, x is 6 meter, here time you know, so you can calculate vx0 equal to, say, how much? Let me check. 6.64 meter per second. Once you know this v0, once you know this v0 value, somebody can you can do different way also. Further, you can use the same formula up to this 1 plus 3 plus 4 equal to 8. You put minus minus y equal to -8 to get this vcx. Okay, or maybe you can, as you told, somebody told, no, if you know this is the velocity, then you put this this distance to get the total distance traveled using this velocity. You can get that expression also. And as you told, s equal to finally what will be the s value? Somebody can come from here also. S plus 6 equal to, okay, s plus 6 equal to vx This is fixed, correct? X0 t. This is, then we need this t value only. What is the t? Time required. This is the distance v0, time required. Then maybe you can, as I told, you can utilize this expression to get the time. So to solve this, what you have to do, whatever 10 plus 2 standard and concept you have, you can use that. Simply, you know what is projectile, what are the values are constant, or what are the values are changing. Okay. You just use that way. Say for example, this type of problem. This type of problem, you can see that its variation is like this projectile variation is like this. It is like this. So if somebody is considering x, in that total interval, x will be 0. In this problem, total interval, this x will be 0. Then you can get some relationship and you can calculate the time required for that one. And somebody can use that, that this is y, total y. Okay, total y in terms of if it is v, if it is theta, then the v cosine theta and v sine theta. Now this v is like this, so v cosine theta and v sine theta. This component wise simple, the simple theory of the your task problem you can solve. Okay, so this is one problem. Yeah, instead of this theta, we have additional term alpha. So a projectile is launched with some velocity from A, determine the launch angle theta that results in the maximum range R up to the inclined of angle alpha, whereas alpha is between 90 to 0 degree, 0 to 90 degree. Evaluate a results with respect to alpha. So, sixth problem, what you have to do? So with this range, this R is the range basically. This is the R in the range. So somebody can have this V0, this V0 in term with respect to this inclined and perpendicular distance with that. Then you can have expression of x, R cosine theta, R sine theta. Based on that, to get the maximum value of this range R, you can get one derivative terms. And from that derivative, you can calculate the relationship between alpha and theta. And alpha and theta relationship for this problem will be theta will be 90 degree plus alpha by 2. This will be the relationship for R max range, this range max. Okay. Now, if we have, you have to, when alpha equal to 0, 30 degree and 45 degree, corresponding theta, you have to calculate. Okay. 45 degree, 30, 120, 60 degree, 45, 135, 67.5 degree. Why I am keeping everything for you? Because I want, based on the concept, you try. Okay. So next day I will start new chapters, that is normal and tangential coordinates, this kinematic, then constant portions. So constant, that is in terms of article 2 by 5 and 2 by 9. Don't worry, the assignment also I will put there, such that you can advance, you can start editing. Next day that theory I'll cover. Then problem sheet 1 and 2, whatever problems you are facing issue, those things I'll solve. Then next week, Tuesday, kinematics, remaining problem will be solved. No kinematic discussions. Then this will be done. Then from this 11th will be kinetics. I need 11th, 15, I think Holi was there on 18. Then this 22 and 25. Syllabus will be over. Okay, there will be one class test and one will be revision.
Hello, sir.
Yeah.
On the class tests, it will be both kinematics, dynamics and statics.
No, don't worry. See, I want to give some grace to you to get good marks, as you many students did very bad in mid semester first class test. It will be only for kinematics. Okay, happy. Class test will be only for kinematics. Problem
Okay,
sheet
sir.
one.
Thank you.
Okay,
Yeah,
sir.
one,
Okay,
two.
sir.
Yes. Then it will be helpful for you, because if something happen, no final end sem also your score was very bad. If then this will be helpful for me, because if I take two class test based on my understanding, I can give weightage of these two class test as per my own. Okay. If I take two class test, I can give weightage as per my requirement for the betterment of the students. Betterment means, like if many students are being suffered, then this strategy, if that way I will decide, and it will be uniform. If I use some rules, it will be uniform. Everything will be Excel based calculations, nothing manual calculation. Understood? In Excel, everything I'll use some formula for the internal assessment. I have only 20 marks for internal assessment, and same uniform marks will be given. Uniform means same weightage. Understood? So if I use class test 5, so everybody will get out of 5 how much you got. If I give class test 2 more weightage, class test 1 less, then that way also I can try. Now question is, we have to decide, I will discuss later also, which date you want to do the class test. If you want to do online class test, I do prefer then do on 15th itself. Understood? Should I tell once again? If you want to do online class test, I have no issue. Then you be very careful, finish everything by 19 and give online class test on 15th itself.
So only dynamics portion. No?
Only kinematics. Problem sheet 1, 2, 3 and 5. I'm just putting now 3 and 5 for the assignment. Due date I am not putting now. Okay, we can see that. Whenever you will give this class test, if you give 29 at the end, then I have to take more syllabus. Then you give on 15 itself, or latest by 18. I believe 15 will be okay. You try to give the class test on 15 itself. Next day we'll discuss. Okay.
Okay, sir.
Okay, sir.
But my suggestion is, if you can give 15, okay, then only these 20 problems, okay, and these problems will be very easy. And whatever new problems I will give, that also will be very easy. I'll not give these problems. I'll give similar problems.
Sir, 18 is holiday.
I know it. Then give on 15 itself. We have no other option. 15. Give class test on 15.
Okay, sir.
Say for example, if 21 you are at the institute, then I cannot take online class test. Okay. You decide and
Okay,
let me
sir.
know before. Okay. I cannot take
Okay, sir.
online test. If you want to give online test, you have no choice other than 15. You
Okay,
plan
sir.
accordingly. You confirm on the
15, sir.
next day. Okay. Okay. I'll
Okay, sir.
quickly
Thank
take
you.
attendance. Okay. And remaining assignments, today itself I'll give, because you can try. Theory, you open the books, that this dynamics by Miriam Craig, each problem you can see, I'll show you. You can check it. This is given, this 2.3 and 2 by 3, 2 by 4. This is the article of the book. You can directly read whatever I told. You know it. Understood what I am telling? This is the article from where I
Yes,
have
sir.
covered the syllabus.
Yes, sir.
Yes, as well as problem has been taken. Let me tell once again other thing also. So like this one, I will put this 2.5 normal and tangential coordinate. Then it will be 2.9 constant motion. You know this type of problem also. This problem sheet 1, 2, 3 and 5. 3 and 5 I have not given you. Now I am putting that. I have not covered the syllabus also. You try at your own and give them this class test. And make sure this class test, you should be honest, be little bit serious. Questions will be easy. Don't take any other unfair means. Solve it. it will be your then say if you are getting 10 out of 10, it will be good for you for the final score. Understood?
Sir, will there be
Okay, sir.
question pattern will be like the previous class test?
Now this time I will give answer any 3 out of 4. Is it okay? There are four problem sheet, correct?
Okay, sir. Okay, sir.
So
Okay, sir.
answer any 3 out of 4. But read all the chapters. Why? In NSEM, it will help you. I have total 9 problem sheet. Here I am giving 4, taking the class test. So if you are very careful and give seriously class test, then it will be easy for you for the NSEM. Time is short. All subject will be accumulated. Okay. No, you will not get much time. Okay. Now at quickly attendance. Just give me 1 minute. Attendance is today is 1/3/22. 1/3/22. Okay. Let's make aerospace 25, 26, 27, 28 absent, 29 absent, 30 present, civil 77 present, 79 absent, 80 absent, 82 present,
79 present, sir.
79 present. Okay, 79 present. 80 is absent, 81 is absent, 82 present, 83, 84, 85, 86, 87, 88, 89, 90 present, 91 absent, 92 absent, 93 absent, 94 present, 95 present. Okay, just a minute. No, this CST 95, CST 58 absent, 59 absent, 60 absent, 61 absent, 62 present, 63 absent, 64 present, 65 present, 66 absent, 67 present, 68 present, 69 present, 70 present, 41 present electrical, 50 present, 51, 52, 53, 54, 55, 56 absent, 57 present, 58 present, 59 present. Don't leave, okay? Then this page is like I'm not getting
Present, sir. 56.
56 is present. Just a minute. Yes, 56 present. Okay, now electrical is over. Electronics 35 present, 36 present, 37 absent, 38 present, 39 present, 40 present, 41 absent, 42 present. Electronics over. IT 53 present, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64 present. Mechanical 49 absent, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60 present. Then metallurgy 25, 26, 27, 28, 29 present. 30 absent. Mining 25 absent, 26 absent, 27, 28, 29, 30 present. Okay, fine. It is over. Those who are absent, once again,
PSP 66
just
present.
a minute. Those who are absent, aerospace 28, 29, then civil 80, 81, then civil 91, then 58 CST, 59 CST, 60 CST, 61 CST absent. Then those who are absent, once again, CST 66 absent. Are you there?
Sir, I'm present.
Okay, 66. Okay. Then just a minute. Then electronics 37 present, absent. Yeah. Then mining 25 absent, 26 absent. Okay, that's all. So as I told, I have to give today two assignments, 2.3 and 2.5. Make sure 2.4 is not included. It is spherical coordinate. I have not covered that one. Don't worry. You go through the engineering mechanics dynamics book, only concentrate on those small portions which I want to cover and give the exams preferably by 15. You have to confirm afterwards. Okay, and that will save time. Okay, thank you students for giving patience. It is already 6:10. Bye.
Thank you,
Yeah,
sir.
bye, bye,
Bye.
bye.
Thank you, sir.
Yes,
Bye,
sir.
sir.
Thank
Thank you, sir. Bye, sir.
Have a good day. Good night.